5.3, connecting f prime and f double prime with a graph of f. Worked out problems on the homework. Use first derivative test. In other words, just take the derivative, see what happens. This is a negative x cubed, so it's kind of probably do something like that. Y prime negative 6x squared plus 12x. Set it equal to 0, and I factor it on the fly. Double check, -6, -2, yep. So I get x equals 0, 2. Plug in 1. Negative, so that's a positive. Negative gazillion, that's going to dominate as a negative, so it's a negative. Positive gazillion, that's going to dominate, it's a negative. So relative min at 0, plug it back in, -3. Relative max at 2, plug it in, 5. I don't buy that. Now I gotta double check. It's making me nervous. 8, 16, -16, 24. Yeah, that's right. Good. All right, let's go look at the other one. I think it's gonna graph something like, well, I can't plug in 0, so something weird here. Y prime equals, leave it, e to the 1 over x times -1 over x squared plus e to the 1 over x. I can cancel this 2 and this x. So I get e to the 1 over x. I'm going to factor that out. E to the 1 over x. That's gone. I'm left with -1 over x plus 1. Set it equal to 0. This can never equal, this always equals positive. Never equals 0. -1 over x plus 1 equals 0. 1 over x equals 1. X equals 1. Now we got a point of interest here at 0. We got to check that out because that causes problems. Plug it all in. Plug in 2 into this, positive, can ignore it, -1/2 plus 1, positive. Plug in 1/2, -2 plus 1, negative. Plug in negative a gazillion. This basically is 0, positive. So we have a, since this point's not defined, it's just going down, we have a relative min at 1, plug in 1, e. Got to graph this one because it's a piecewise, figure out what's going on. 3 minus x squared, non-inclusive. X squared plus 1, inclusive. So I'm not doing any calculus here because I'm just going to look at the graph and I'm going to say there's a min here. There's not here because of that. So I'm just going to say local min at 0, 1. So it goes down forever, goes up forever. concavity test, in other words, the second derivative. And we're just looking for concave up, concave down. Now I actually graphed this. It looks something like this, if I'm not mistaken, not pointy, curvy. Y prime equals negative 4x to the third plus 12x squared minus 4. Oh no, I have to find 0. Pay attention to the details. Double prime equals negative 12x squared plus 24x. Negative 12x squared plus 24x equals 0. Negative 12x, x minus 2 equals 0. We need to check at 0, 2. One in the second derivative. This is negative and this is negative, so that's a positive. Oops. Let's slow the brain down. 3, positive, negative. This graph is definitely wrong. I'm gonna have to go check that out. Must be a little knuckle in there somewhere. Now let's go graph that and see what we're doing wrong. Negative x to the fourth plus 4x to the third minus 4x plus 1. I was going to say I should zoom 6 it, but well, I have to, but it's negative x to the fourth, so it's going to come from down below. It's got a hump, but it's going to come back down eventually. Interesting. So concave down, concave up, concave down. This is going to be down. Let's check. Negative 1 makes that positive, stays negative. So this is concave down. So this is just a horrible graph. Just something like that. Terrible, terrible, terrible. All right, so let's get her done. Concave up, 0 to 2. Concave down. Negative infinity to 0. And 2 to infinity. On a roll. All right, x to the 1/3. Oh boy, that's tricky. You know what? Let's not graph it. Let's find out what happens. Y prime equals negative 1/3 x to the negative 2/3. Y double prime equals 2/9. Found a mistake on my math. Negative 5/3. All right. There is no way to make that equal to 0, period. So let's plug in some values. There is a point of interest at 0 because you can't put 0 into the derivative. So let's just try that. So let's try 1 into the second derivative and I get positive. Let's try negative 1. So x to negative 5/3 is x over to the 5/3, and negative 1 to a negative negative is going to give you a negative. And there we go, we're done. Concave up, 0 to infinity. Concave down, infinity to 0. How do we do? 5 minus x to the 1/3. 5 minus x to the 1/3. Yep. Concave down, concave up. All right. One to go. Y prime equals e to the x, y double prime equals e to the x. That's always positive. So it is concave up. Now this is the point where I failed to read the question. Thank goodness I have an answer key sitting next to me. I was given a limited range. Why 0 to 2 pi? I have no idea. That doesn't make any sense at all. 0 to 2 pi. Pardon me. Can't be concave up at an endpoint. If you got that wrong, don't lose any sleep. Does not matter at all. By the way, we know that this graph's like always concave up. Onwards. Find all points of inflection of the function. So looks like we're taking second derivatives. Find all points of inflection. This is tricky. Leave it. That will be 1/2 9 minus x squared to the negative 1/2. In other words, put on the bottom to negative 2x. Plus root 9 minus x squared. That equals, multiply this by root 9 minus x squared, or root 9 minus x squared. Negative 2x squared plus 9 minus x squared all over square root of 9 minus x squared equals, I don't know why I have a 2 here, my mistake. Negative 2x squared plus 9 over root 9 minus x squared. Second derivative equals just like before. I'm going to do this common denominator again thing up here. So it's going to be root 9 over root 9. It's going to be 9 minus x squared to the bottom, so 3/2. Negative 4x is negative 36x plus 4x to the 3rd. I think I see a mistake in my math, and now I got to think if I made that mistake. Sure looks like I did. Gonna have to pause this. 36x, negative 36x plus 4x to the third minus 2x to the third plus 9x slash 9 minus x squared to the 3/2. So I went with common denominator here. Root 9 minus x squared over root 9 minus x squared. Brought all of this down, made it 9 minus x squared to the 3/2. You don't care about, I only care about the top. So let's put this together. 2x to the third minus 27x equals 0. Plot next to the third. I think, no, I made a mistake. Oh boy, I made a lot of mistakes on this old one. A lot of mistakes. Okay, I think I figured out my mistakes. So this becomes x 2x squared minus 27 equals 0. X equals 0 comma plus or minus 27 over 2, square root of 27 over 2. And I don't care about that. I'll explain why. This is undefined when x is greater than 3 or less than negative 3. This is greater than 3 and less than negative 3. So we cross that one off. And we just go to our number line and say what's going on at 0. And we can also go up to 3 and up to negative 3, but we can't actually go past them. That's very bizarre that I put a 1 when I said 3. So plug in 1 to the second derivative. What a nightmare. The bottom is positive. Don't have to worry about that. It will always be positive no matter what I put in, 1 or negative 1. And then the top is this thing, 2 minus 27 is negative. So over here we get concave down. When I put negative 1 here, I get negative 2 plus 27. So then it's, so we have to write it somewhere. POI. By the way, it's 0 comma 0. You plug in 0 here. Wow, that's about as horrible a problem as we're likely to ever see here. So let us hopefully find something a little less crazy. Y prime, leave it, derivative plus derivative, leave it, negative x to the third plus 12x squared minus 3x to the third equals negative 4x to the third plus 12x squared. Hey, I actually did it right this time. When I say I found an error, I don't mean in here, I mean in my answer key. So apologies for the confusion. Y double prime equals negative 12x squared plus 24x. There's going to be a 0 at x, and then negative 12x plus 24, 12x equals 24, x equals 2. And then 2. So we do this. Plug in 1, 24 minus 12, positive, concave up. Plug in 3, plug in a massive, huge number, the negative's going to outweigh. Same thing over here, plug in a negative massive number. So POI, 0 comma and 2 comma 0 comma 0. Comma 16, unless I'm mistaken. By the way, I should have graphed both of these. and seeing what's going on when I was done. But I'll leave that one up to you. All right. I'm going to distribute this right away. Y equals x to the 3/2 plus 3x to the 1/2. Y prime equals 3/2 x to the 1/2 plus 3x halves x to the negative 1/2. Y double prime equals 3/4 x to the negative 1/2 plus negative 3/4 x to the negative 3/2 equals, let's take out the let's take out 3/4 x to the 1/2. Negative 1/2. So leaves me 1 minus 1 over x. Set this equal to 0. I'll do it here. 1 minus 1 over x equals 0. That's 1 equals 1 over x. X equals 1. Now, notice that if I plug in 0 right here, it causes a problem. It's a point of interest. So we'll check out 0 also. Just because you never know. And this goes into the second derivative, which is here. The square root of a number. So we really can't go over here. This is undefined. So what happens? Well, I can't put negative here. So yeah, it's a square root. So nothing's going on there. And then would imply this is going to always be positive because we've got positive numbers. And 1 minus 1/2 is positive. I'll give up. And 1 minus 1 over 1/2 is 1 minus 2. So this is negative. Concave down. So we have a POI at, actually I've been doing these. 1 comma, plug in 1, yep. Oops, 3, 4, yep. 4. Again, really should graph that, see what's going on. While being thorough. All right, so x over x squared plus 1. This looks like it's going to be a joyous time. Y prime equals low, d high minus high, d low, x squared plus 1 squared equals x squared minus 2x squared negative x squared plus 1. Yep, over x squared plus 1 squared. Y double prime equals low, squared plus 1 squared d high, 2x. No, can't fit it there. Low, x squared plus 1 squared d high, negative 2x minus high, negative x squared plus 1 d low. It's going to be tricky. 2x squared plus 1 2x over some stuff that I don't really care, because I only care about the top for finding zeros. Now I got to simplify all this. You're going to have to take my word for it. Equals 2x to the 5th minus 4x to the 3rd minus 6x. See if I agree with that. 4x times x squared times negative x squared. I'm going to do this because that's going to cause problems otherwise. 2 2x to the fifth. That should cancel. Let me see. Maybe I should go do these somewhere separate. I'll do these on a separate sheet of paper and just blast this out, see if I get what I think I'm going to get there. Negative, oh, I'm going to do all this stuff first. X to the fourth plus 2x squared plus 1 times negative 2x. Negative 2x to the fifth minus 4x to the third minus 2x. Over here, we have squared minus 1 times x squared plus 1 times 4x. That's going to get me x to the fourth. They're going to cancel minus 1 times 4x. There it is. I missed that. 4x to the fifth minus 4x. 2x to the fifth minus 4x to the third minus 6x. Wow, that was brutal. Okay, over x squared plus 1 to the fourth. X equals 0 clearly. And then when we do some factoring, we're going to get plus or minus root 3. Let's go take a look. Can we, yeah, we can plug in anything here. So we number line it. And we get -2 into this. Always positive, don't need to worry about it. Freakishly big negative number. This is going to dominate, it'll be negative, so that's negative. Concave down. 1, 2 minus 4 minus 6. That's negative, concave down. Freakishly big positive, that's going to be this. And the hard one, -1, so -2. Plus 4 plus 6. So it's positive. So we have POI negative root 3, negative root 3 over 4, 0 comma 0, n root 3 comma root 3 over 4. That is hard. Alpha y equals x over x squared plus 1. So at negative root 3, we should see a point of inflection. 0 is definitely a point of inflection. Window -2 to 2. You got a min there. It says right here it goes from concave up to concave down, here from concave down to concave up. Pretty lame. Try it one more time. Did not mean to do that. I meant to go from -5 to 5, 2 to 2. Let's see how we did. Yeah, so this is clearly concave down. Right about here is point of inflection. Clearly concave up, concave down, concave up. Wow, that's wild. Well, that was fun. Hopefully find some easier problems to do. Wouldn't count on it, knowing me. Use the graph, the function f to estimate f prime, f double prime. where they are 0, positive, and negative. Okay. So this is the graph of the function. So f prime equals 0 at that's -2, so careful. -1.4-ish. And that's 2, 1, 1.4. F prime is greater than x from -infinity to -1.4, and from 1.4 to infinity. And f prime is less than x from -1.4 to 1.4. Now over here, let's do second derivatives. F double prime of x, F double prime equals 0 at, looks like there's only 1 point of inflection. It looks like it's 0. These are all x's, so I'm not being clear. My apologies, but just keeping it simple. F double prime is less than 0, concave down, -infinity, comma, 0. If double prime is greater than 0, those words greater than at 0, comma, infinity. Sure, whatever. Over here, looking for our peaks and valleys. Again, this is 2, so 1 point, yeah, call it 1.4 again. F prime is equal to 0 at -1.4, comma, 0, comma, 1.4. F prime is less than 0 at -1.4 to 0. And 1.4, comma, infinity. F prime greater than 0 at -infinity. Having trouble writing my infinities today. -1.4 and 0, comma, 1.4. F double prime equals 0 at, yeah, looks like about -0.8, -0.7, and 0.7. F double prime less than 0 at, let's go with -infinity to -0.7 and 0.7 to infinity. And F double prime greater than 0 at up -0.7 to 0.7, approximately. Well, that was supposed to be an easier problem, but whatever. (13 through 14), describe the motion of a particle, find acceleration, yada yada. V of t, x bar of t, -2 minus 2t, a of t, x double bar of t, -2. Negative v of t, t of greater than 0. So this is getting bigger and bigger, and it's negative. So the v of t never equals 0. And a of t never equals 0. So position at time 0, it starts at 6. It starts moving and accelerating left. That's it. All right, let's check this out. X prime of t equals v of t. Kind of got that backwards. You'll live 6t minus 6t squared. A of t equals x double bar of t, 6 minus 12t. V of t equals 0, 1, 6t minus 6t squared equals 0. Factor out of 6t. I'm left with 1 minus t, so add t equals 0 and 1. So a of t equals 0, 6 minus 12t equals 0, and t equals 1/2. All right. So what's the velocity at time t equals 0? It's 0, but it starts becoming, put in 1/2, 6 minus 6/4. So it's positive. And there it is. And then, yeah, okay. Let's go particle. Starts at 0 with 0 velocity. It, again, 1/4 here. Accelerates right until t equals 1/2. When it starts to slow down. It stops at t equals 1. And then accelerates left. Well, that's exhausting writing that out. Okay, shown below is a graph, position function. It did not print out. Wow, that's quite upsetting. Why it didn't print out? Whatever. I'll draw it in. There are no units on the y-axis. At 6, it valleys. Then at just before 10, we'll call it a 10. Peaks and heads out here to 15. Peaks a little less high, so that's not really drawn perfectly, but yeah, it's not too bad. So you got horizontal tangents at approximately, we'll say, like 2 and change. So horizontal and t equals about 2.2 at 6, and then a little bit less, like 9.8. Apologize for the crummy graph. What does that mean? Well, that means this is the distance from origin, so it is going away, it's coming back, it's going away, it's coming back. So when is particle's velocity equals 0? So v of t equals 0 at t equals 2.2, 6, 9.8. And I will write seconds because it did give me units, although it doesn't say the distance. So what is the acceleration equal to 0? Well, that's going to be here and here and here, where it's given an initial velocity, it keeps slowing down, and it stops and it starts to accelerate, and it stops, then it starts to slow down. There's going to be POIs at approximately t equals 4, about 4, it's fine, and about 8 and about 11. We're not getting any more precise than that. Therefore, A of, that's not what I wanted, A of t equals 0 at t equals 4, 8, 11 seconds. Sorry for my crummy ease. Woo! This one, I'm going to be really, really lazy. I'm going to pull my old answer key out and just substitute it directly in. So what you should do is put all this in your calculator. All right. Now, I'm not going to put it all in the calculator. I'm going to show you how you would do it. You would go the whole stat, edit, put it into L1. I need to clear this. And I need to clear this, clear, right? Put in L1, L2, quit out of there, and stat, calc, and do a logistic regression right there. Do that, you should get this, and you should definitely do this on your calculator. All right. So the question is, chart below shows increase basic cable subscribers. This is a good one for logistics. There's only so many people who can get cable. Population keeps growing, but after a while, you kind of maxed out. So, 30 million households, there's only so many households. And even though they're adding more, there's only so many that get cable, they'll get something else, so on and so on. So they use logistic to model it. How well does the curve fit the data? Yada, yada, what year? It fits extremely well. Fits a really nice logistic curve in here. All right. The POI is approximately where we want to go half. So about 14 and a half. So just about 15 come down, right about 4.58. This is where the subscriptions were growing the fastest. And the rate was approximately at 4.58. This is wrong. 6,170,000 subscriptions per year. Nope, that's right. I thought this was a rate there. So it's adding about 6,178,000. You might say, no, look, it's adding 11 million. Well, that's how many they had. So right about here, they should add about 6. So 11 plus 6 is 17. Right there, that's where they were maxing out. Now you can see they're only adding 5, only adding 3, only adding 2. It's pretty good logistic. So definitely put that in your calculator. It's definitely one to practice. Second derivative test. All righty. I'm a nerd. I got to put this in correct order. Y prime equals negative 3x squared plus 3. It says use the second derivative test, find the local extreme. Well, that doesn't work for me, so I'm using the first and second. All right, factor out negative 3x squared minus 1 equals 0. X equals negative 1 comma 1. There's no domain issues here, 1. So plug in 0, I get a positive. Plug in 2, negative, it's going to dominate, it'll be negative. Plug in really huge negative, it's also going to dominate, it'll be negative, the square will dominate. So we have a relative min here, and a relative max here. So second derivative. I feel like that's wrong. No, it's not. So if I plug in a positive, I've got a negative. If I plug in a negative, I've got a positive. So there's a point of inflection at 0. There's a local, I'm going to call it a relative min. And by the way, let's take a quick look at the graph. Something like this. Relative min at, that was weird, at maybe 1 comma 3. Relative max at 1 comma 7, and a POI at 0 comma 5. Yeah, there it is. Getting it done. Y prime equals 15x to the 4th minus 75x squared plus 60. I'm not going to do the work here. There's going to be up to 4 of these. There are 4 of these. We can factor and then graph it. It doesn't matter. So we're going to have x equals -2, -1, 1 and 2. Number line them. Don't know what the graph looks like. It's a positive x to the 5th. So I'm looking at 1, 2, something like that. So as we can see, this is going to be positive and this is going to be positive. And you can plug in your numbers and find out that it does this sort of thing. All right. It's going to work either way. And second derivative. So you take out an x, you get a 0, and then you get, let's go for it, 30x squared. No, that was a mistake. That was a mistake. I didn't finish writing my 150. 30x squared, 2x minus 50. It's not x squared, it's just x. Having a rough time today. 2x squared minus 5. So x squared equals plus or minus square root of 5 halves. It's fine with me. So here we go again. And x equals 0. Negative root 5 halves, 0. Positive root 5 halves. Plug in freakishly large numbers. It's going to dominate. It's positive. Freakishly negative number. It's negative. It's making sense. Negative, positive. And it's going to go back and forth. Plug in -1. -60 plus 150. Plug in +1. That was -60 minus 150, so that's negative. I'm making mistakes here, most likely. -1, positive, right? +1, right? Got it. Okay, here we go. Local max at 2 comma something and 1 comma something. We'll get that done in a minute. Local min at -1 comma something, 2 comma something. I'm going to show you how to do that quickly. And POI at -5/2 comma something, 0 comma something, and 5/2 comma something, or not a space there. Okay, here we go. Y equals 3x to the 5th minus 25x to the 3rd plus 60x plus 20. Table set, ask. Not mean to hit that. Table set 0. I don't think that'll matter, but I'm thorough. So when I put in -2, 4, plug in 1, 58. Plug in -1, -18. Plug in 2, 36. Plug in 0, 20. Plug in negative square root 5 divided by 2, 5.694. 5.694. That should be 5.694 over there. Plug in 45.694. Oh, odd. That's what I call working for a living. Almost there, boys and girls. Okay. Y prime equals, leave it, -e to -x plus derivative e to the -x equals e to the -x times -x plus 1. X equals 1. Always positive. Plug in a massive number, get a negative slope. Plug in a really negative number, we get a positive slope. Y double prime equals, leave it, -1 plus -e to the -x, -x plus 1. Factor out that e to the -x again, leaving us with -1 plus -x minus 1, also known as x minus 2. This is x minus 2. This is always positive. X minus 2. Plug in a huge number, we get a positive. X minus 2, really negative number, we get a negative. So cross-hatching. Let's see now. Should be an absolute max. At 1 comma 1 over e. I feel like I've done this problem before. And POI at two comma 2 over e squared. This one I got a graph. x second e to the negative x. I'm already zoomed in, so we'll see how this works out. And there it is. So max at 1. 1 over 2 is 1 over 3 is 0.3-ish, about 0.3. And then there's a POI at 2, 1, 2, where it goes from concave down to concave up. Woohoo! And we're flying. Use the derivative function and find the points at which have both max, minimum, point of inflection. So, very kindly, they gave me the derivative. Second derivative could be a little tricky, but we'll see where it goes. I'm not even sure how I did that. Oh, yeah, I did. Okay. Anyway, let's do this one first. There's a that gives me my zeros, 1, 2, and 4. 1, 2, 4. Always positive. 0, negative, negative, positive. 1.5, negative, negative. Also positive. I was surprised by that, but that's accurate. 2.5, positive, negative, negative. 4.5, positive, positive, positive. So we have a relative max and a relative min. Okay. So our graph's going to look something like this. This is 1, this is 2, this is 4. Sure, whatever. All right, and off we go again with rewriting y prime to make it easier for me to take a derivative. X squared minus 6x plus 8. Y double prime equals, oh, shoot, let's leave this one alone. X minus 1 squared, 2x minus 6 plus 2x minus 1, no chain rule issues, times x squared minus 6x plus 8. Y double prime, I can factor out an x minus 1, which is nice because I'm looking for zeros. Leaves me with x minus 1 times 2x minus 6 plus 2x squared minus 12x plus 16. Let's combine. Y double prime equals x minus 1 times 2x squared plus 2x squared is 4x squared. Negative 2 minus 6, negative 8x, negative 20x. Positive 6 plus 16 plus 22. Using the calculator or quadratic or whatever, I find that I have zeros at 1, 1.634 and 3.366. Number line it one more time. 1.634, 3.366. Cut into the chase because we've been doing this video for a long time. Negative, negative, positive, positive, negative, negative, positive. So POI, POI, POI. And I am being lazy. I'm not writing out all the coordinates. Yeah, done. Finally, it's probably the longest two videos I've ever made for a single unit. Graphs of the first and second derivatives are shown below. Add a sketch of a possible graph of f. That's the point. So these are blue and red. So I'm gonna have to go with a slightly different color. The pen works. Cool. Be nice if they told me which was which. So red is f prime of x. Blue is f double prime of x. The derivative is 0, so we have a peak up here. And then, let's see if I can track it. Second derivative is negative, so it's concave down. So then I'll have a point of inflection about here. Negative derivative till here, so it's going to be a, I'll move it up here just for the fun of it. Right about there. And then right about there, I'll hit 0 again. And then I have another point of inflection about here. So let's say about, yeah, about there. So now this is where I'm getting messed up. And derivative is always positive, so yeah, so that should be about a peak right here too. So about something like this. That worked out a lot better than I thought it would. I'll make this dot really big so it looks like I know what I'm doing. And that one too. And ooh, I hit this one so well I can't even see it. God, I'm good. Something like that. Good luck and happy mathing.